Supply chain management and lean manufacturing. This is a topic without any calculations. So if you know the meaning of the terms, that's what mostly is tested. Supply chain management. First of all, let's understand what is meant by supply chain. Supply chain activities cover product development, sourcing, production, logistics, and the information systems needed to coordinate these activities. So basically, buying raw material, then production, finished good, delivering these finished good to the customers. This whole process is what you call supply chain. Supply chain. Once again, see, supply chain activities cover product development, then sourcing, that's what buying raw material, production, so logistics, that means storage, supplying the goods or delivering the goods, all that, and the information system needed to this. Supply chain management is the active management of supply chain activities by the members of a supply chain with the goals of maximizing customer value and achieving a sustainable. See, focusing on each of these activities, how we are buying raw material, how we are doing production, where we are storing, this is about storage, where we are storing the goods, how we are storing it, how we are delivering it. Focusing on each of these activities so that we deliver good value to the customers, deliver value to customer, is what you call supply chain management. So in for example, in purchasing raw material, you can see, okay, how best we can buy the raw material so that with low price we give the best value to the customer. Likewise, each activity, supply chain management is the active management of supply chain activities by the members of supply chain with the goal of maximizing customer value. The supply chain firms endeavor to develop and run their supply chains in the most effective and efficient ways possible. The organizations that make up the supply chain are linked together through a physical flows of products and through flows of information. See, there is a supplier to you, supplier. Then your company, the factory. Sometimes for delivering goods, you may have another partner who is delivering goods on behalf of you. So there are many companies that are connected in a supply chain. It's not just one company. It's not only the manufacturer. This is the manufacturer. Then before the manufacturer, supplier. After the manufacturer, sometimes other processes like delivering can be done. So many organizations. Physical flows involve the movement, storage, and transformation of raw materials and finished goods. Physical flows are the most visible part of the supply chain. Basically, the raw material, until it goes and reaches the customer, it goes through the hands of all these people who are involved in the supply chain. Supplier, procurement department, storage, factory, again storage, delivering. So that's what they mean by this paragraph. But the information flows are just as important. Information flows allow the various supply chain partners to coordinate their long-term plans. So that's why we will be discussing in this chapter, enterprise resource planning systems are there. Computer softwares which connect you with all these parties. So supplier will get regular updates. It's easy for you to give regular updates, placing the orders and all that. So information flow is important. Goal of supply chain. The result of effective supply chain management is fewer stock outs. We should not run out of inventory at the retail level. Reduction of excess manufacturing by the manufacturer. Manufacturing too much and keeping it in the stock is an unwanted cost to you. So if I reword it, manufacturing at the right level, not excess manufacturing, not shortage of manufacturing, right level manufacturing, because you don't want to have a stock out, you don't want to have excess stock. So both of them put together, manufacturing at the right level. Reduction of excess finished good inventories. Fewer Rush orders. Rush orders. That means sometimes you accept the rush orders, sometimes you miss the deadlines and you do rush deliveries, avoiding such activities. So, low inventory, no stock out, no excessive inventory, no rush deliveries. These are the objectives of supply chain management. Each company in the supply chain is able to carry lower inventories, reducing amount of cash tied up in inventories for all. Of course, if you keep too much of inventory, you are blocking your capital in the inventory. When you reduce the inventory, that releases the money back to you. So that is one of the objectives, reducing the inventory. Some supply chain management goes so far as the retailer allowing the distributor or manufacturer to manage the inventories for them. Imagine there is a manufacturer, he has connection with many retailers, retailer 1, retailer 2. Retailers can be supermarkets, shops. Okay. So sometimes this manufacturer himself might give software to this retailer where his inventory is monitored by the manufacturer. When the inventory levels go down, manufacturer will know automatically. He directly makes a supply. So even the inventory management of retailers are sometimes done by the suppliers, allowing the distributor or manufacturer to manage their inventories for them, shipping product to them automatically whenever their inventory of an item gets low. Such a practice is called supplier managed or vendor managed inventory. Supplier managed or vendor managed inventory. The name itself gives you the meaning, supplier managed inventory. Along with the benefits of supply chain management, issues and problems can arise because of communications problems, trust issues, incompatible information systems, and the required increases in personal resources and financial resources. See, to implement this, first thing, whether this company, say retailer, are they happy to share the stock information with the manufacturer? Sometimes they might think, no, we don't want to share this information. And see, when we have extra like softwares, ERP systems, when we are implementing, sometimes our existing staff may not be capable of handling such systems. Then we may have to hire somebody who is capable of handling such systems. So these are some of the challenges of having a proper supply chain management. So that's about supply chain management. Now we are coming to lean manufacturing. What we mean by lean management, lean manufacturing, simply that says remove wastage. Remove wastage. So lean manufacturing means doing the manufacturing activity by removing all the wasteful activities. The emphasis on lean manufacturing is on cutting out waste in the manufacturing process. Waste is anything other than the minimum amount of equipment, materials, parts and working time that is absolutely essential to add value to the customer. See, if a product effectively needs 2 hours of working, beyond 2 hours, every minute you are spending is considered to be waste. Every minute. If the product takes 20 kilograms of material, if that is what the standard, beyond 20 kilogram, every kilogram you are spending is considered waste. So that's the meaning of this. Anything other than minimum amount of equipment, materials, parts, working time that is absolutely essential to add value to the customer. Waste is anything that does not add value to the customer. What is the meaning of not adding value to the customer? Say you are doing a furniture manufacturing plant. Cutting the furniture, fixing the furniture, painting the furniture, all these are value adding. Polishing. Okay. You make a mistake and redo that table, redo that piece of furniture. That is not a value addition. You cannot tell the customer, do you know I had to redo this piece? Can you pay me double the price? Customer will slap on your face. Why? Redoing, because you made a mistake. What's the value to the customer? So anything that doesn't add value to the customer is waste. Waste is anything that does not add value to the customer. I think I was talking about this in ABC also. Activity based costing also, I said some activities are value adding, some activities are non-value adding. Identifying and eliminating waste is the primary focus of lean manufacturing. Adding value to customer is not the same thing as adding value to the product. That's the other thing. See, I always take these examples of Tata Nano cars, because Tata Nano originally they did a research, and to whom they wanted to pitch this product, there was one type of customers who wanted a car for 1 lakh Indian rupee. So that's the market. They saw people, sometimes a family rides on a motorbike. 2 adults, 2 kids, all together 4 of them, they go on a motorbike. So that is the segment they wanted to pitch this product, Tata Nano. So in this Tata Nano, for example, having a hi-fi audio system, it might improve the product becomes better. It is actually adding value to the product. But to the customer, that is a useless product, useless value addition. Do you know why? Customer, he expects a basic car. His focus is the minimum price that he wants to pay. You add a hi-fi audio system and increase the price by 20,000. That's not a value addition to the customer. So the point is, value to the customer is from customer's perspective, your target market's perspective. What do they value? What they do not value. Whereas product improvement means just any extra feature you are adding to the product is product improvement. So that's what they say. Adding value to the customer is not same as adding value to the product. If extra options added to a product are not things the customer wants or is willing to pay, they may well add value to the product, but they do not add value to the customer. This is the same example I was telling. Goals of lean manufacturing. Operations are streamlined to give the customers what they want, when they want it, at the lowest possible cost, within least amount of time. Lean manufacturing strives to produce products on time, so no delay, not early manufacturing, on time manufacturing, using few resources as possible. In other words, efficiency, highest efficiency, with little input, getting the work done. Better than those of competitors. You have to see how you can outperform your competitor in terms of product, in terms of value. Faster and cheaper than competition. Faster manufacturing. That means if the order is given, how quickly you can supply, faster. Right. Important. Lean manufacturing identifies 7 types of wasteful activities. One is overproduction, that you can understand, producing more. Second one, delay. Delay is also considered to be waste. What is delay? See, there are processes arranged one after the other. Process 1. After process 1, process 2 is done. After process 2, process 3 is done. Let's say process 1 is slow in working. Because of this, process 2 had to wait until process 1 sends them the goods. So the waiting, right? That waiting for processing parts sitting in storage. So such delay is a waste. Transporting in between processes. Let's say this process is in one city, this process is in another city. You have to transport the work in progress from one factory to another factory. That's a wasteful activity. Overprocessing means sometimes you try to deliver more value than the customer wants. If customer wants a basic product, give basic. You don't have to give an advanced product. But sometimes, even though customer wants a basic product, you overprocess it, you spend more resources to make it more than what customer wants. So that is not necessary. That's what they call overprocessing. Process to the right level that the customer wants. Inventory. Keeping inventory is considered to be waste. So how do we avoid inventory? Manufacture only when there is demand. Motion. Moving parts more than the minimum amount required to complete the complete and ship them. So somewhat similar to transporting. Transporting is transporting between storage locations and all. Motion is parts between the processes, parts between the factories. Somewhat similar in a way, transporting, motion. Last one, making defective parts, making mistakes. These are identified as wasteful activities, and all of them must be removed in lean manufacturing. 5 principles. First one, customers. That means customers first. Well, understand the customer. Have a good communication, good understanding with your customer, so that you can satisfy the customer. Because we are doing the activities, what is the ultimate task, ultimate goal? Value to customer. Delivering value to customer. So unless you understand what the customer wants, how do you deliver this? So the first point is customer. Second one, value stream, somewhat similar to supply chain. Value stream means who are involved in this process. Supplier, procurement, manufacturing, delivering, after sales delivery, and the IT systems required for all these activities. So this is what you call value stream. The people and the processes involved in delivering the value to the customer. Next one, flow. Flow means make a smooth flow. There shouldn't be delays, there shouldn't be waiting for processes. Make it a smooth flow. Streamline your flow. Next one, pull. Pull means, I don't know whether I explained earlier, the manufacturing system is considered 2 types, push system and pull system. Push system means we don't listen to customer, we don't manufacture to customers' requirements, we make what we can do and we sell it. This is how earlier they were doing. For example, like 50 years, 80 years ago, there were only very few car models. If it is India, Ambassador was there. USA, Ford was there. Only very few models were there, very few manufacturers. And there were barriers of transportation. Making a car in India and transporting that to another country is a big hassle. It's not so easy. So the competition was much less, very less competition. Availability of choices was very less. So customers didn't have the bargaining power. You go to the market and say, look, this is our product. If you want, you buy it, otherwise leave it. Customers had no choice. They had to buy from you because you were the only seller. Right. This system is known as push system. You make what you can make and you sell it in the market. But now, because of all the transportation barriers removed, the competition has increased. You may be manufacturing in India, but you can be competing in anywhere in the world. You may be manufacturing in USA, you can compete anywhere in the world. So this has increased the competition. Now customers have more choices. If you go and say, this is what I have, if you want you buy, otherwise get lost, customer will say, you get lost. Because they have so many choices. So now what we do, we listen to the customer. What do you want? How can I impress this customer? So get the customer requirements first. Get a signal from the market. Do market researches first. Identify what customers want and then sell the product. That's what you call pull system. Customers pull what they want from the companies. Last one, continuous improvement. Continuous improvement means don't set big targets. Sometimes what companies do, during the whole year they don't improve. Next year they put a target, we won't improve 20%. They achieve that, they maintain the same performance. Next year they put another 20%. What lean manufacturing or Japanese manufacturing techniques say, don't set such big targets. Instead of having annual increment of 20%, target monthly 2%. Monthly, compared to last month, this month I improved 2%. Next month 2%. Even compared to monthly, then have weekly percentages. Weekly, 0.5%. So looks like a very small increment, right? Compared to 20% extra, 0.5% improvement looks feasible. So short term, small incremental targets must be set on a continuous basis until you achieve the highest performance, 100% efficiency. Machine downtimes and batches, we know that machine downtime seems breakdown. It's a kind of a wastage. Having minimal machine downtime when changing from manufacturing one time to manufacturing a different item, one item to another item, is an important component for lean manufacturing. For example, see these aircrafts, there is something called ground time. That means they land in an airport. Before they take off for the next flight, there is a ground time. That's an absolute waste for the company, the non-flying hours. So mostly companies focus on how they can reduce it. That's why you might see when you're getting down from the aircraft, very quickly the other team will come to clean the aircraft, another team will be working on making the aircraft ready, the mechanical team. So everyone works so fast so that the aeroplane is ready for the next takeoff. So reducing downtime is so important in any industry. Similarly, often large batches are assumed to be more economical than small batches due to excessively long or difficult changeover procedures. So if you do small batches, after each batch if you take a break, you are spending too much of time in breaks. Instead of that, if you do a large batch and take a break, it's better. But production of large batches result in large on-hand inventories. Yes, if you do a big batch, then the inventory will increase. So we have to strike a balance between these two. Ideally, batching is not done at all in lean manufacturing. The goal of lean manufacturing is to maintain continuous flow, meaning once you begin producing a product, you keep it moving through the value stream without ever placing it into a holding area for later processing. So what this says is, in lean manufacturing, don't do products batch by batch. It must be a continuous flow without a breakage, without a stoppage. It must be a continuous flow. Manufacturing cells. If you take the traditional setup, traditional arrangement, think about a furniture maker, or let's say textiles, garment factory. Earlier what they did, they had specialized divisions. There will be 3 divisions. First division, the staff there are experts in cutting the material. So let's say this product makes 2 types of products. They are making shirts and pants. So material for shirts, materials for pants, both are given to these guys. What they do, according to the design, they do cutting. After cutting, they pass all these materials to the next department. The next division will be specialized in maybe stitching. So each of these pieces they get from the previous department, they do their part of work and they pass it to the next department. So basically, the employees were specialized. The company is believed in specialization, and final output comes here. So one of the important features of specialization, if you take cutting department employees, they will know cutting only. They wouldn't know what happens in the next process. They wouldn't know what happens in the following process. So even they do cutting, they don't get to see how the final product comes, how much of impact they had on the final product. They are not going to see, because they did their part and they passed it. So only the final department, last department, will get to see the final product. So this specialization concept was questioned. We started questioning, come on guys, you are not seeing the final product. So how do you know the impact you have on the customer? We will rearrange it. Now what we do, this is what you call cell arrangement. This is one cell. Within that there is a small cutting division. stitching division, finishing division. This is for shirts only. Shirt materials go here, they do cutting, they do stitching, they do finishing, output comes here. Similar thing, but it is within one cell. So what happens when the final product comes out, this guy will see, because they are working in a very close small cell where they see the final outputs. Maybe 2 guys are working here, 2 guys are working here, 2 guys are working here. This is one cell. Similarly, another cell, another cell, another cell, maybe another cell for pants. Shirts itself, you may have many cells like this. So basically, we are making sure each one knows how the final output comes. And another important feature, let's say these 2 employees are absent on a particular day. Then one from cutting department, one from finishing department should be able to come and continue this work. We can't wait and say, look, they are absent, we will do the work tomorrow. No. So from specialization, we are moving to all-rounders. All-rounders, they know all the work. They are not specialized in cutting only. If stitching they need to do, they will do it. If finishing they have to work, they can do it. This kind of arrangement is what you call cell arrangements. Cell arrangements. Another advantage of this, transportation, moving materials from one process to another process will be reduced. See, for example, in the earlier department structure, this may be in one floor, this may be in another floor, this may be in another floor. So from here to here, somebody has to carry the goods here. But now, this cell is going to be within a room. So once the material comes in between the processes, the movement is much less. Within one room, they are working. It's not a big department as such. So movements will be reduced. This is all the benefits of cell structure. Manufacturing cells. Kaizen is another name for continuous improvement, which I already explained. What is it? Don't set big targets. Set short-term, small, incremental targets on a continuous basis. We never stop the learning process. We never stop the improvement process. And some of the benefits are given. You can read that, benefits of lean manufacturing. That's it about lean manufacturing. So we studied about supply chain and lean manufacturing. Just-in-time inventory. Just-in-time inventory means not having the inventory. There are 2 purposes, guys. Many of you think JIT means remove inventory. Why? Because we are saving the cost of having inventory. You think that's a benefit? No. That is, of course, a benefit. But the biggest benefit is the difference between, look, there is one restaurant which is selling food already prepared. It's there in the buffet, right? There is another restaurant, they prepare only for a la carte. That means you go and place the order according to the order they are making. Many a customer might prefer this one because they might want modifications, because here if you say buffet, they might have standard items only. See, somebody who is allergic to, let's say, tomatoes, he wants a curry without tomato, he may not be able to get it from here, buffet. But if it is a la carte, if he is going to order and get the food, he can tell, please make it without tomato, please make it with more spice, please make it with more salt. He can do all that, right? So that's the main purpose behind JIT. Because the moment you have inventory, customers have to choose from the inventory. We remove the inventory and wait for the customer's precise requirements. Accordingly, we manufacture and give them. They will be more satisfied. In this process, you are removing the inventory as well. Meet customer demand in a timely manner with high quality products at the lowest possible cost is what you call JIT, just in time. All this is, we have already discussed, pull system, push system, everything is discussed. Minimizing the inventory storage, we have discussed that. See that in the cell system I explained, each worker knows how to operate all machines. So no more specialization. We are talking about all rounders. All rounders. Yeah, this all you can read it, not much. Kanban system means, say there is a process here, process 1, process 2. This is cutting departments. Continuing the same example, garment factory, if the first department is cutting, second department is stitching, they will have a inventory here. Cutting department doesn't bother how fast stitching department is working. They will keep on working at their speed and they will be filling this inventory. Stitching department will take from this inventory and they will do their work. This is traditional. Let's say there was a breakdown in stitching department. Stitching department is closed for 1 week or 1 hour, 2 hours. Cutting department will continue their work. They are going to pile up the inventory here. This process is changed in the Japanese management. In JIT system, what we do, they had a flag system. What is a flag system? See, customer comes and gives the order, right? That's what the first even the trigger is that. Customer gives the order. Then only the last process will start working. When they start working, they need supply from the previous process. They raise the flag. So this process, they see this flag, then they understand, all right, next process won't supply from us. They start working. If they want raw material, they put the flag. Then the previous department, procurement department, buys the raw material immediately and they supply to process 1. Then process 1 supplies to process 2. Once the supply has come, the flag will be down. This kind of system. So there is not going to be an inventory between these two processes. There is a clear communication between the processes. When the process needs something, they put the flag up. Because see, early days, 30 years, 40 years, 50 years back, they didn't have all the communication systems like what we have now. Now, it's not flag. It might be an email, it might be a message or whatever. But early days, they had this flag system. They had a flag. So that's what they remember, visual record. Visual record. You see this flag and then you start working. You need supply, you put your flag on, your previous department will give you the supply. This is Kanban system. Originally developed in Toyota. Toyota was the pioneers of all these guys. JIT, lean manufacturing, Kanban systems. So many concepts that we call modern, so many concepts that we think are effective, Toyota pioneered. So originally this was developed by Toyota. Right, now we are going to look at the software systems. We have MRP, MRP2, ERP. MRP is materials resource planning or materials requirements planning. Material requirements planning means you have a software just to plan your material requirements only. That means how much of stock is there, what is the material requirement for the next period, do we have enough, should we place the order. All this is analyzed in this MRP, materials requirement planning. Sometimes we say MRP1 because there is another one we are going to call MRP2. The important feature, remember, it includes only materials in its planning. It doesn't include labor, it doesn't include finance, it doesn't include HR, just the materials planning only. The basic software. You can just read this, but that's all the main points. Then from MRP, material requirements planning, we came to MRP2. MRP2 is manufacturing resource planning. Manufacturing resource planning means it includes material, labor, machine capacity. All that is going to be included. All that is going to be included. So it will be a software where you can do the planning of all this. How many units we are going to manufacture, what is the material requirement, when and when we have to buy, how much we have to buy, monitoring the storage. Same as for labor, how much is our capacity, each month what is the production plan, do we have enough labor, do we have to hire part-time laborers, all that. Similar for machine. So all that can be analyzed in MRP2. Manufacturing resource planning, not materials only, all the manufacturing. But the problem with MRP2 or the room for improvement is non-manufacturing items like finance, HR, they are not integrated. It's only manufacturing. Then only we came up with this ERP, enterprise resource planning. That's all in all. All in all, it connects all the resources, finance, HR, material, labor, manufacturing, planning, machine capacity, everything will be integrated. Usually what happens, you will have a centralized database where you have all these stored, all these are programmed. Then HR department will have access to a certain part of this data, whichever they need. Finance department will have access to another certain part of data, whichever they need. Likewise, each of them will access different parts of this whole data. This is called enterprise resource plan. Cash, raw materials, fixed assets, even employees, everything. Benefits, you can read it, there is nothing much. Outsourcing, a company giving its work to a third party. Remember, third party, because why I emphasize on that, there is another one called offshoring. Offshore activities means you are not giving it to a third party, you are setting a branch somewhere else. For example, a software company in Canada might have a development division in India. It's their employees, it's like their company itself. That is offshoring. Outsourcing means you give it to a third party. A training center might give the accounting activities to a third party. When a company outsources, an external company performs one or some of its internal functions. Often non-IT companies give their IT services on outsourcing usually. Security, we usually give it like that. There are specialized security firms. Cleaning sometimes. Cleaning and janitor services, we give it to outsiders. By outsourcing certain functions to a specialist, management can free up resources within the company in order to focus on the primary operations of the company. It may also be cheaper to outsource a function to a company that specializes. It may be cheaper, but you know why? For example, if you take IT, for you to hire a IT server manager and all these people might be very costly for you. Instead, what you do, you hire a company, so they may have all the experts, they don't have to work full time with you. Once in a week, if they spend a couple of hours with you, it might be enough for your company. So it's cheap. You get it at cheap but better services. The disadvantage of outsourcing is that the company loses direct control over these functions. You lose the control. Lose the control in the sense now there is going to be two risks. One risk, information leakage. Your information might be leaked, which can be shared with the competitors. Risk number one. Risk number two, sometimes you may need some flexibility. You want to get some work done extra, more than what we usually do, or you want to change the way of doing things. All that is not going to be possible because you have a fixed contract with the third party. Any changes to the contract, they will say, okay, send us another contract, pay us extra. So the freedom for you to change the things, flexibility will be less. Let's see some questions with all this.
D.
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 Correct. Both of you got it right, so I don't have to explain it. Let's go to one of them. 4. Okay. Consider the following manufacturing related activities: conducting That will be classified as value-adding activities. Okay. Conducting the final assembly of wooden furniture, moving completed production to the finished goods. Remember in ABC I explained this. Moving goods is not adding value to the customer. You cannot say one factory is in America, one factory is in India, so we had to move these goods, so we spend a lot of money. Customer will ask, why did you have one factory in America? Why do I have to pay cost for that? So see how you can minimize the moving good. The name I gave for this activity is non-value adding, but cannot be avoided. So what do? You minimize it. So definitely that's not value adding. Second one. Third one, painting automobiles. Yes, assembling, painting, machining, all these are part of the production. It adds value. Setting up machine related to a new production run. Arguable. We can argue either way, but last one, reworking on defective goods. Yes, I think one of you said reworking. It's not value adding. You made a mistake, then you rework on it. Can I tell the customer, see, I made a mistake, so I had to rework, I spent 1 hour extra, please pay me? Customer will not pay for that. It's not a value addition for them. Why did you make the mistake in the first case? So 5 is not a not a value adding activity. So if we look at these points, that 2 cannot come, 5 cannot come definitely, 4 is arguable. We see only this option is there because all others have 5 in it. 5, 5, 5. Reworking, remember, reworking is never a value addition. See, setup cost means you do that in between batches. Like servicing our car, we do that for machines, you setting up the machine for that batch. What happens when you do JIT system? You will have small sized frequent batches. You can't have one standard design big batches. Why? You are manufacturing according to the customer requirement, right? Customer requirement can be different. So today or this week what you are manufacturing, next week what you are manufacturing could be different requirements. So frequently you will have to change your design, change your layout, change your setup. So setup cost will be very high in just-in-time system. It will not be lower setup cost. It will be higher setup cost. Others are benefits. Total storage cost will be reduced. Manufacturing lead time will be reduced. Lead time reduced means you do manufacturing faster. Lead time means starting the production, ending the production, the gap. So that will be lower. Lower total rework cost because you will focus on the quality. You will get the work done correctly in the first attempt itself. So rework will not happen. So all these 3 are advantages. Last one, lower setup cost. Wrong statement. It will be higher setup cost. Higher setup cost.
Outsourcing.
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 Correct.
Reduce cost.
First one.
Yeah.
One of the benefits of implementing JIT manufacturing system is reduce cost for reworking defective outputs. Yes. So that's a sort of theory questions you get. I have done 1, 2, 3, 4, 5, 6 questions out of 16. The other 10 questions are for you. Shared Services Center. Shared Services Center means sometimes you may have a factory 1, another factory 2, another factory. There might be a storage in common for all these. Storage is not an essential element of production. Even without storage, the production can happen, right? Factories can work. So this is what we call support center, service center. It's not a production center. It provides support to the factories. Support center. This support center's cost, let's say the cost of running this storage for a year is $15,000. This $15,000 has to be shared, had to be apportioned to these three factories. So how we are going to apportion that? This is what we are going to see. We will find a basis. Maybe if it is storage, we can find out how much of space is utilized by factory 1, factory 2, factory 3. Sometimes we get canteen, a common canteen for all of them. So maybe based on number of employees, factory 1, factory 2, factory 3, see how many employees are there. Accordingly, you do that. Right? Regarding this only, we are going to do the calculations now. So let's go and see the slides. Two treatments of service centers. Allocate the cost of the service center to the production departments. Expense the service center cost as they are incurred. This is what we are talking about now. Allocate the cost of the service center to the production departments. This is one method. Other method, don't allocate to the production department so it doesn't come into the cost of sales. You can put it as an expense like administrative expenses and all. You can include this also. But the thing is, storage is a production overhead, right? It's connected to the production departments only. It's not something like administration, not something like marketing. It's connected to the production. It's providing support to the production. So it's more logical to charge these overheads with the production cost itself. Anyway, we have two methods. One is charging with the production cost, other one expensing it like a non-production cost. The allocation process, the first method, depends on the number of service departments. If there is one service department, process is different. If there are more than one service department, the process is different. We are going to do calculations anyway. Right. One service department means, let's see if they have an example. Okay, look at this. Easy Breezy has one service department. It's maintenance department that serves in manufacturing and sales departments. Maintenance department has practical capacity of 5,000 hours. Maintenance service is available each year. The fixed cost of operating maintenance department are $247,500 per year. The wages for maintenance people and the supplies they require are variable costs budgeted at $25 per hour. Budgeted maintenance usage by the manufacturing and sales department is 4,500. Wait, so these are the two departments. Manufacturing, sales are two departments. They have a common department, shared center called maintenance department. Maintenance department's cost I need to allocate for these two. This is the overall scenario. There are two departments, manufacturing and sales. Maintenance is a support center. Support center costs are given here. Fixed cost this much, variable cost this much. Support center cost I have to share it. Using a single rate method. Single rate method means take all the overheads. All the overhead, that means variable overhead, fixed overhead, take all of them together and divide by the basis. So you get one rate that represents variable, fixed both. See what we are doing here? This was the fixed cost given, 247,500. They are finding the variable cost also. How do they find the variable cost? 25 is the rate per hour. You are budgeting to work 4,500 hours. Capacity doesn't matter. Variable overhead depends on hours worked. You work, then only variable cost is incurred. So 4,500 is the usage hours budgeted. Multiply, you get total fixed overhead, which is 360,000. Fixed plus variable. Allocation basis is hours. How many hours did you budget? 4,500 hours you budgeted. So total overhead of 360,000 divided by 4,500 hours, you get 80 per hour. This is a single rate that represents both fixed and variable. Both fixed and variable. Then First department, manufacturing department. Okay, let's see what is it here. The actual maintenance hours used by the manufacturing and sales department are this. So using this rate, 80 per hour, you charge the overheads. Manufacturing has worked 3,600. 3,600 into 80 will be the overheads to them. You remember we found applied overhead. Somewhere I gave you this equation earlier. Applied overhead. How do we do? OAR multiplied by the actual basis, actual hours. Because when the hours are worked only, you keep applying it, applied hours. So use a similar formula. The rate is 80, overhead application rate is 80. How many actual hours they worked? 3,600 hours they worked, multiply. For sales also do the same. This is total cost allocated. This is single rate. If it is dual rate, similar process, but fixed cost will be dealt with separately. Variable overhead or variable cost will be dealt with separately. We don't combine them, then that is dual rate. I'll explain more with the questions. Okay, for now that's enough, right? There are single rate, multiple rate. Single rate, fixed and variable overhead together. You take one rate and using that rate you apply. Multiple rate or dual rate means fixed overhead separately, variable overhead separately. You will do the calculation. Now the example we saw, there was only one service department. Maintenance department was the only service department we had. Now we are going to see multiple service departments. If there are more than one department. Whenever there are more than one department, we have three methods to deal with it. One is direct method, step down method, reciprocal method. I'll take an example and explain all this. Say factory 1, factory 2, service department 1, service department 2. The overheads are given to you, or the costs are given to you. Factory 1 100,000, factory 2 80,000, service 1 50,000, service 2 90,000. See, service 1, let's say this is canteen. Service 2 is, let's say, cleaning. So if you look at canteen, canteen is going to be used by factory 1, factory 2 as well as cleaning people, right? All the departments will use canteen. So this 50,000 technically I have to allocate here, here and here. Because even cleaning people are using canteen. It's providing service to them as well. So let's say the percentages they are giving, canteen they are giving 50% to factory 1, 40% to factory 2, 10% to factory 3. Not factory 3, cleaning service 2. So how this canteen is being utilized, this is how it is being utilized. 50% of canteen resources are utilized by factory 1. Maybe they have more people working there. 40% of canteen is consumed by factory 2. 10% of canteen is consumed by service department 2. Similarly, the cleaning department. How that is being used, 30% here, 60% here, 10% here. Why here? Cleaning department is used by canteen as well. So cleaning department's cost must go to factory 1, factory 2 and canteen. Right? This is how information is given to you, let's say. What is the direct method telling? Direct method says, these percentages are there, right? Factory 1, factory 2, service 1, service 2. Service 1 percentages 50, 40, 10. Service 2's percentages 30, 60, 10. What direct method says, whatever the link between these two departments, service departments, just cancel that link. What is the meaning of link? From service department 1's cost of operations, 10% we have to allocate here, right? Cancel that 10%. We are ignoring it. Similarly, service 2 gives 10% to service 1. Cancel that. We will consider only service 1 to factory departments, factories, and service 2 to factories. Nothing in between service departments. So it's actually an approximation. It's not an accurate method. Just to make the life easier, we are doing an approximation. What is the approximation? We are cancelling these percentages. Whatever sharing that happens between service centers are cancelled. Now what will happen? Service 1 cost is 50,000. That 50,000 is going to be allocated between factory 1 and factory 2 only, right? Okay. Look at the percentages, 50, 40. So I'll put 50 by 90. It's not percentage anymore. Why it's not percentage anymore? It doesn't add up to 100 because we cancel this 10. We cancel this 10. So 50 by 90 to this department, 40 by 90 to this department. Similarly, service 2, how much of cost was there? I remember 75,000. No, 90,000. Service 2 has 90,000, right? Take that 90,000. Three by 9, 30 by 90, 60 by 90. Where do I get 30 and 60? Here. And remember, it's not percentage anymore. Once you cancel one of the percentages, then it doesn't add up to 100. If it doesn't add up to 100, it's not percentage. It is not percentage. This way of allocating the service center is known as direct method. All the connections between the service centers was cancelled in direct method. Now let's go to next one, step down method. Just a second, let's add a page. Okay. Step down method means we will not cancel both percentages. One of it we will cancel. Factory 1, factory 2, service 1, service 2. We had percentages 50. These were service 1. 40, 10. For service 2 we had 30, 60, 10. One of this will be cancelled. Out of these two percentages, one of that will be cancelled, which is usually given by the question. If it is not given, take whatever the bigger percentage, keep it, smaller percentage will be cancelled. But I have given you equal percentages, right? So if it is equal, then we look at the cost percentage, cost value. Service department 1, how much cost is there? 50,000. So let's cancel that. From service 1 to service 2 will be cancelled. Anyway, that will be given to you in the question, which one not to consider. Only one will be cancelled, the other one will be kept. Okay, how the working is going to be now. What are the figures they already have? 100, 80, 50, 90. 100, 80, 50, 90. Let me do for service 2 first. If I do for service 2, out of the 90, 30% will come here. 27,000 will be added to the factory 1. 60% will come to factory 2. 54,000. 10% will come here. 9,000. If you see here now, this says 59,000. This 90 is cancelled, because that is what we have given to the other 3. So this is cancelled, finished. Now this 59,000, service 1 in the other order. 50, 40, service 1 you cancel this 10, right? So 59,000 into 50 by 90, 59,000 into 40 by 90. Cancel this 59,000. We get the totals after this. This way of allocating is known as step down method. Step down method means one of the connections between the service centers was cancelled. Not all of them, one of them. It's one of them. In this case, I decided to cancel service 1 to service 2 percentage. Usually smaller percentage is what we cancel. Here percentages were equal. So then I looked at the cost, smaller costs. S1 has a smaller cost, 50,000. So from S1, the percentage was cancelled. But your exam questions, mostly they will tell you which one to cancel. Last method we have reciprocal method. Reciprocal method. Yes. Reciprocal method is a bit lengthy method. I'll show you here. F1, F2, S1, S2. What figures we had? 100, 75 was it? 80. 180, 50, 90. From S1 you got 50, 40, 10. From S2 you got 30, 60, 10. Now let's give, we are going to make equations. We are not going to cancel any of these percentages. Let's make equations. Look at the first equation. F1 equals 100,000 plus 50% of S1. 0.5 S1 plus 30% of S2. 0.3 S2. F2 equals 80,000 plus 0.4 S1, 0.6 S2. 40% of S1, 60 S2. Then S1 equals 50,000 plus 10% of S2, 0.1 S2. S2 equals 90,000 plus 0.1 S1. 10% S1, right? 90 plus 10% S1. Here, right. You got 4 equations. There are 4 unknown variables. We can solve it. The process is first solve these last 2 equations. S1, S2. Find the S1, S2 answers. That is some intermediary answer. Don't go analyzing maths here. What is that S1? What is the S2? I'm not going to explain that. But get the S1, S2 answers. Substitute here for S1 and S2 in the first 2 equations. You will get the final cost of F1 and F2. That means with the F1's 100,000, how much is going to come from S1 and S2 added all together? That gives you an answer. So this is considered to be the most accurate answer because it doesn't cancel anything. There is no approximation. This is the most accurate method. Compared to this, step down method is an approximation. Compared to step down, direct method is even a bigger approximation, less accurate. Right, just one question I'll show you how to solve. S1.
Sir, can you show me explain this equation one more time, that F1 and F2?
Sure. F1, look at this column. F1's column. F1 has 100,000 already, right? 100. And 50% of what? 50% of S1. From S1 it has to get 50%. So 50% means 0.5. 0.5 S1. And it has to get 30% from S2. 0.3 S2. Similarly, for F2, 80,000, 40% S1, 0.4 S1, 0.6 S2. Similarly, if you look at S1, S1 has 50,000 in it already, 50,000 plus 10% S2, 0.1 S2. Last one. Okay.
Yes.
Yeah. But I'll just show you one solving. 50,000 plus 0.1 into S2. I'm going to copy this. This is S2. 90,000 0.1 S1. Multiply this 0.1 into 90,000, 9,000. 0.1 into 0.1, 0.01. So this is 1 S1, right? So bring this S1 and subtract it here. This 1 S1, 0.00, no, not 0, 01 S1 is 50 and 9, 59,000. So this is 1 minus 0.09. If you subtract it, you get 0.99. From that you get S1 equals 59,000 divided by 0.99. That's around 59,060. So 59,600. Yeah, 59,596. Now substitute that in the second equation, you can get S2. S2 equals 90,000 0.1 into 59,596. So that will be 95,960. You got S1, you got S2. Go to the first two equations, substitute S1 and S2, you will get F1 and F2. That will be the final answers for F1 and F2. Okay. So this is what the reciprocal method is. They're explaining each of those methods. That's all we have. Let's see a couple of questions as well. Okay, try answering this, please. Which method they are asking? Step down method. They say allocation beginning with maintenance department. Okay, so let me show you. Which are the two departments they have? Two supporting departments, maintenance and IS, information systems. Okay. They want to start with machining, is it? No, maintenance. Right. Maintenance department is what we are going to do first. Maintenance department 6.3. Cancel that 6.3. I'm going to give it to these two only. I'm not going to give anything to the information system. That is the meaning of starting with maintenance. We are starting with maintenance. First one you give it to all. First one you give it to all for information system, machining and assembly. That's how we did last time also. Go back and see. First department I took, it went to all three. Step down. Where is step down? Here I took S2. S2 went to F1, F2 as well as S1. Then next one when I'm doing S1, I don't give anything to S2. I give it to others, F1, F2 only. Can you see 5,900 or 59,000? I gave only for these two. So similar process. First allocation you are doing, you give it to everyone. On what basis? We have maintenance hours. Can you see 4,000, 6,000, 10,000. Maintenance cost we can take in that Propose 4 by 4 plus 6 plus 10 is 20. Here you multiply 6 by 20. Here you multiply 10 by 20. How much are you getting here? 1260. How much do you get here? 1890. How much do you get here? 3150. Now get the totals. This plus this has to be added. 1452, 1260, 2712. This is which one? Maintenance department. Now let's go to IS, Information Systems Department. Now, see, I already have finished machining, right? So you don't give anything back to machining. Don't give anything to machining. You are going to give only to these two. That means we will consider only these 2 hours. 4000 hours, 500 hours we will consider. This we will not consider. So cancel this 2712 150. That amount has to be multiplied by 4000 divided by 4500 here. That amount multiplied by 500 over 4500 here. This 500 is not considered. Right. How much is that? Two 150 into 4000 divided by 4500. 2410 800. 2712 150 500 divided by 4500. 301 350. At them, they are asking the total, right? What is the requirement? The total overhead charge to each of the operating departments. Yes. So with this 4 million, they ask charged amount or total? Let's look at the answers. Answers are 8, 7. Let's get the total. 4, 1890 and 2410. Let's add all this. 8, 300, 800. Do we have an answer like that? There is only one answer. Correct. Let's double check the other one also. 2,3150. That's all, right? No.
30.
This also 301 also. So 510 5451 350. Yes, that's right. Right, here I'm going to stop with that for today. Tomorrow what we will do, we have not done enough questions in these areas. So tomorrow's plan, I'm not going to teach anything new. We have to clear some backlog questions. Which ones? These ones. Variable and absorption costing theory questions we didn't do. We didn't do any of them. So some of them we have to do. Calculations, I did some questions, but it's not enough. We need to do a little bit more. So we'll do some more questions. Shared services center, multiple services center, estimating fixed and variable cost allocation. That's also a small topic. We need to do questions on these areas tomorrow. Right, so this week that's the plan. Next week what we will do, we will take the last 4 topics. So next week I can finish this, the whole block, the questions on costing systems can be finished next week. Section D. Okay.
Okay.
After that we will start a new topic.